You either had it on Monday or Tuesday. So go ahead and read the do now and answer questions 1, 2, and 3. Because I'm just going to go over to keep the video time short. So pause me unless you want to do it with me. All right, you did the do now. We're studying systems, and there's a lot of word problems and real life problems that can be solved by the idea of systems, because constant rate happens in the real world. So, number 1, an oak tree is 2 feet tall and is growing at a rate of 1 foot per year. Write a linear function in y goes mx plus b form / slope intercept. Okay, constant rate of change is slope, and we have a starting point of 2 feet. So this equation for the oak tree is y equals 1x plus 2. Sweet. A 6 foot tall maple tree is growing at a rate of 0.5 feet per year, or half a foot per year. Write a linear function in y goes mx plus b. And here again we have a constant rate and a starting point. So y equals 0.5x, and we start with 6. Cool. Those are the 2 equations. One of our standards this year is you writing equations from word problems. I'm trying to step you through it to help you write the idea, learn the idea. All right, 3. How many years will it be before the trees will be the same height? So that's what we can answer this question. We could plug in numbers, try x is 1, x is 2, x is 3. But what I wanted to do is to try to do a system. So we have 2 equations in the same problem. We have y equals 1x plus 2 and y equals 0.5x plus 6. All right, so I placed them in the brackets, and then we're going to solve the system. Well, you read it. Y equals 1x plus 2. Y equals 0.5x plus 6. Well, these things that I'm circling are both equal to y, and I taught you that Mr. Moran equals awesome, right? And that's one of the methods we can use, substitution. So this equals this, and we can write that down, that 1x plus 2 equals 0.5x plus 6. All right. And that's substitution, right? And that's the Mr. Moran equals awesome method. All right. We're going to take, I'm going to take 2 away from both sides. Sure. And now what the great thing is that I taught you is that none of this other stuff is new. It's just putting it together is the new part, right? Take away half of an x from both sides. 0.5x equals 6. Okay, and then divide both sides by a half. Oh, sorry. I messed up. I forgot to take away 2. You noticed that, didn't you? 6 minus 2 is 4. Sorry, over 4. Okay, and 4 divided by a half is not 2, if you got 2. This is saying how many times does this fit in here? Right, that's one way to think about division. So you have 50, 0.50, 1, 1.5, 2, 2.5, 3, 3.54. So we have that x equals 8. So we answered it by solving the system. We found that it's after 8 years it'll be the same height. Cool. But we can also find out maybe like how tall they're going to be. So we can find our y. Let's take the top equation. You can choose either. And let's plug the x in that we found. Cool. So in 8 years, they'll both be, oh, you can't see, 10 feet tall. Okay. And we're going to keep looking at word problems as we go through this chapter 5. Okay. Your class did have homework. If you're watching this video, you had questions 3, 6, 18, 19, 22, and 23, which were to start in class last lesson and to finish. So you were practicing solving systems. Okay. And we're going to keep going. All right. If you're confused about these, next time we actually have a live class, you can come and watch it. You can come and ask me. All right, this is 5.2 substitution method, day 3. Okay, so give yourself that heading. And just to remind you, to solve a system of linear functions, we need to find where the two lines cross, which is the x and y that makes both equations true. Okay, I just want to keep reminding you, when we solve systems, we're finding the point where the two lines cross, but it's also the x and y that makes it true. All right, so I have a little puzzle here. It's a classic math puzzle. It says the sum of two numbers is 39. The greater number is 3 times the smaller number minus 5. What are the two numbers? Okay, well, I guess they add up to 39, so I don't know. Could be anything, right? And here's a tricky thing. What if they were decimal numbers, right? What if they're two decimal numbers? Or what if one was positive and one was negative? Like, how many different things could you find, right? There was like a ton. I don't know. I guess I could guess and keep trying and use both. Well, this problem is actually a systems of equations problem. We can solve this by thinking about that we actually need to find and write the two equations so we can solve the system. Okay, there are actually two equations written in this problem. So here's how we're going to do it. Let's take that first sentence. The sum of two numbers is 39. And when we think about systems, one way to think about it is like, is there a total? Because we're trying to write equations, and often is 39 tells you that yeah, we got an equal sign. We want two numbers that equal 30, basically, right? But we don't know the two numbers. We just know that the sum of them is 39. The cool thing is, in math, when we don't know something or we have an unknown, we get to use something to represent it. What do we use when we don't know something in math, an unknown? Variable, of course. And what variable might we want to use, right? Very often, x. But we have two numbers, and we're not going to use x twice, so maybe x and y are our two unknown numbers. Right. Now we have to take this next part. The sum of two numbers is 39. Well, we don't know them, so we can say x plus the y equals 39. All right. Boom. We've got our equation. We've got equals, we got x and y, so we have a linear equation here. All right, let's try to find the other equation in this system. All right, the greater number is 3 times the smaller number minus 5. Well, it says the greater number is, right? So the is kind of like an equal sign. Not every time. You have to read it carefully, but in this case it is. The greater number is equal to 3 times the smaller number minus 5. Okay. Well, we don't know which number is greater, x or y. You get to choose either. Isn't that great? Let's just call y the larger number. So y is equal to, and then we have to say 3 times the smaller number minus 5. So 3 times, well, if y is a large number, that means x has to be the smaller number, minus 5. Boom. We have our system. There are the two equations that were hidden in the word problem. And now we can actually solve the system to find what those two numbers are. So, and you're adding this in your notebook if I didn't say that. All right, I'm just going to put the equations into this system notation. Okay, and now I'm going to solve. X plus y is 39, and y equals 3x minus 5. So it's always good to read them. Hey, this is like last lesson's homework. They both don't say y equals like they do now. but 1 does. Oh, so I'm going to substitute this in where y is in the other equation, right? So x plus y equals 39. X plus, well, I'm going to replace y with what the second equation says y is, which is 3x minus 5 equals 39. I can swap y for 3x minus 5. I can swap these two. Awesome. Okay. That's the new stuff. Substituting one equation, one part of an equation into the other. And now that is the only new thing. Now we can distribute, because there is a 1, so we get x plus 3x minus 5 equals 39. You know how to distribute. You know how to combine like terms. You know how to solve equations by doing things to both sides. And you know how to get down to x. So x, which we decided is our smaller number, is 11. Okay, now we just need to know the other number, and then we have this problem solved. I'm going to take the second equation, because it's, it's right there, and it tells us what y equals. So y equals 3x minus 5. Plug 11 in. Y equals 3 times 11 minus 5. 33 minus 5. Y equals 28. All right, there are our two numbers. 11 and 28 add up to 29, and they work on the next equation as well. So there you go. We found the answer, and we wrote the two equations. We'll keep talking about writing equations and practicing it, because it is an important skill, and we can use them to solve more complex problems. Okay. So I'm out. I have report card night tonight. If this is 2021 during the pandemic, you're gonna do a graded classwork. It's not gonna be in groups because obviously we don't have class. But there is a graded classwork that I want you to complete. Okay, during class time. And there's a homework posted. Okay. The graded classwork is due it's due on the 9th by 11:59 p.m. Okay? So your graded classwork is due by 11:59 p.m. on that day. I hope that you get it done in class. But if you don't, it needs to be in by 11:59. And as always, the homework is due on our next class. Okay? All right, that was our lesson for lesson 38. Sorry.